Hello everyone, and welcome to this lesson on understanding algorithms. Today, we are going to learn one of the most important concepts in computer science, algorithms. An algorithm is simply a set of steps used to solve a problem. In this lesson, we will learn what problems are, what algorithms are, how flowcharts work, what pseudocode means, and how programmers use algorithms to create software. Don't worry if you are completely new to programming. Everything will be explained step by step using simple examples.
What is a problem? A problem is simply something that needs to be solved. Examples include finding the shortest route, calculating student marks, logging into a system, or even making tea. Computers are designed to solve problems quickly and efficiently. An algorithm is a step-by-step set of instructions used to solve a problem. Good algorithms must be clear, follow the correct order, and solve the problem correctly. A simple, everyday algorithm is brushing your teeth. This involves a sequence of steps, like picking up the toothbrush and putting on toothpaste, which must be followed in order to achieve the desired result of clean teeth. A good algorithm should have 4 key characteristics. It must be accurate, giving the correct result. It must be efficient, using less time and resources. It needs to be consistent, giving the same result with the same input. Finally, it must be unambiguous, meaning the instructions are clear and have only one meaning. Algorithms are important because they are step-by-step instructions that help computers solve problems quickly and accurately. They are used in many places in our daily lives, such as Google Maps, ATM machines, and YouTube recommendations, making our lives easier. Google Maps is a great example of an algorithm in action. It finds the shortest path, avoids traffic, calculates travel time, and suggests alternative routes, all by exploring millions of possible routes in seconds to find the best option for you. A flowchart is a diagram used to visually show the steps of an algorithm, making them easier to understand. Programmers often design flowcharts before writing code. Flowcharts use special symbols. The oval symbol indicates the start or end. A rectangle shows a process or action. The diamond shape represents a decision point, typically with 2 or more outcomes. The parallelogram is used for input or output. Arrows show the direction of flow. This flowchart demonstrates the simple process of making tea. It breaks down the task into clear, easy-to-follow steps. Boil water, add the tea bag, pour water, and then enjoy the tea. This flowchart illustrates a login system. The program starts, asks the user to enter a password, and then uses a decision symbol to check if the password is correct. If correct, access is granted. Otherwise, the user is asked to try again. Pseudocode is a simple way to write algorithms using English-like statements. It is not a real programming language, but it acts as a blueprint, helping programmers plan solutions before they start coding. Pseudocode uses common keywords. Send displays output, receive gets input, and set assigns values. If is for decision-making, and else provides an alternative action if the condition is false. This simple pseudocode example asks the user to enter a name. The program first displays a message, receives the input, and then displays a welcome message followed by the name entered by the user. This pseudocode example demonstrates adding 2 numbers. It asks for and receives 2 numbers from the user, sets the total to the sum of the 2 numbers, and then sends the total to be displayed. Variables are used to store data, like a score of 75 or a student named John. A key characteristic is that the values stored in variables can change during program execution.
Good variable names should clearly describe the data they store. For example, first name, total marks, and average score are good names. These names help programmers understand the purpose of the variable immediately. Names like X, ABC123, or temp are poor choices because they do not clearly explain their purpose. Imagine reading a large program with thousands of unclear variable names. It would become very difficult to understand the code. Good naming makes programs easier to read, debug, and maintain. Constants protect important fixed values from accidental changes. For example, pi is always approximately 3.14. The number of days in a week is always 7. Constants protect important fixed values from accidental changes.
Arithmetic operators perform mathematical operations. This includes addition, subtraction, multiplication, division, whole number division, and remainder, often called MOD. These are essential for calculations in algorithms. Here are examples of arithmetic operator results. Remember to understand the order of use for operators to get correct results, especially with whole number division, DIV, and remainder, MOD. The IFL structure is used for decision-making. In this example, if the mark is greater than or equal to 50, pass is displayed. Otherwise, fail is displayed. This flowchart calculates the average of 3 marks. It receives the marks, calculates the sum, divides by 3, and then displays the final average. An algorithm is the step-by-step plan to solve a problem. A program is the actual code written in a programming language. Algorithms are the essential planning stage before programming begins. A bad algorithm can have several issues, such as missing steps, the wrong order of instructions, unclear guidance, or forgetting to include necessary inputs or outputs. A good algorithm is detailed and complete. To summarize, algorithms solve problems step by step. Flowcharts offer visual logic, and pseudocode helps design programs. Variables store changing data, and constants store fixed data. Algorithms are fundamental and used everywhere.
Thank you for watching this video on understanding algorithms. We hope you now have a clearer grasp of this foundational concept in computer science.